Hello friends, welcome back to the bench. Thank you very much for joining me. Our patient is the patient from yesterday, or well, as far as you're concerned, it was yesterday. It wasn't actually yesterday. Anyways, so we replaced the EC chip, right? Then what we see is that 3.3 and 5 volts are coming up or coming on for 2, 3, maybe 4 seconds and go away for maybe a second, maybe 2 seconds, right? And it's cycling. So my initial explanation what's going on was that the 3.3 goes on or goes up. It supplies a BIOS chip and it powers on the CPU. Then CPU is going to load the BIOS. It will need memory to run the BIOS and take it from there. If anything goes wrong during that process, then it is natural that maybe it will just reboot. So that was my initial thought, that this would explain what's going on. I did not suspect short because when we do have a short, it's typically a spike on the oscilloscope that you see that the voltage is going up and immediately drops because the short was detected. Typically when there's short, or actually never, you'll never see a short when the voltage goes up for 3 seconds or 4 seconds and then it shuts down because of the short. But there's 2 things that I missed. Number one, after I finished the video and everything, I noticed that the charging light on the computer, it flashes. Very quick flash, every 4, maybe 5 seconds. Just a quick flash. What does it mean? It means a short. Second, just because 3.3 and 5 are going up, doesn't mean there isn't a short. It's just no short on 3.3 and 5. Correct. But there's a power sequence, right? So first those 2 voltages go up. They supply the BIOS and everything. Then another voltage goes up, and that voltage that goes up later is the one that is shorted. So the entire procedure is terminated by the EC chip. In addition, you guys gave me a very good idea what this might be, and everybody seems to agree that this is definitely something wrong with the LDO, that it's probably short somewhere on LDO. However, if the EC chip was shorted, then we wouldn't have the spike on 3.3 and 5, right? So the EC chip is powered. EC chip works, it turns on first stage, then the second stage or whatever, and that's the one that has an issue. That's why we have the flash on the battery. So we have a short. There's one thing that I kind of ignored, and I know I shouldn't have, but I figured, well, let's see, let's just put it back together and let's see what happens. And obviously it doesn't work. So now my attention is drawn to that thing. So first time when we discovered that the EC chip was shorted, this diode or this resistor, I don't remember which one at the moment, but they supply, I think this diode supplies the EC chip, right? So when the EC chip is shorted, this LDO regulator over here gets hot, but it gets really hot, right? And the way I discovered this one to be getting hot was because I just accidentally placed my hand over the board, and when you touch it with this part of your hand or your arm, obviously you're gonna feel the burning sensation, right? Much better than with your finger, typically. So that's how I discovered that this was getting hot, really hot, red hot, right? And the short was past this diode, right? and this diode, let me show. So this diode, right, the LDO, the output is, I think, on this pin over here, that's the output, or this one. Regardless, I think this one, yeah. Yeah, and we go to the diode over here, and this diode, in turn, this is LDO EC, this line over here. I'm not clear what this chip is for. This chip is 2 PNP transistors, and both bases are connected through 220K resistor to 1 meg resistor. This is 1 mega ohm resistor, this one. And this is ground. So I'm not sure what exactly the purpose of this is, but the output of it, one output, this one, this is LDO, the overall LDO. And this one, this via over here, goes to EC chip, and that's the LDO EC. So this is dedicated just for the EC, but in addition, we supply the emitters here and here, or was it, I don't remember the configuration, but I remember bases are in the middle. And these two bases are just connected to ground, so this technically always turns on. And our LDO output is here. So when our EC chip was shorted, we had a short over here. We do not have the short over here. But this chip, this LDO regulator, it takes the input voltage and it produces, I actually don't remember, I think it was like 2.5 or 2.6 volts. It's not 3.3 regulator. I have a data sheet somewhere. So the short was over here, right, when the EC chip was shorted. Now we don't have a short here, but this chip is getting hot. So this is the first thing that I noticed, because as soon as I connected it, I first examined it under a thermal camera, and this is lighting up very bright. However, it's not as hot as it used to be when there was a 1 ohm short on the EC chip. This was getting very hot. Now it is not getting very hot, meaning I can touch it and it's just barely warm. It just looks very bright on the thermal camera, but it's not hot. So we don't have a 0 ohm short. We don't have 1 ohm short. We have a low resistance somewhere on the output of this chip. Now I might be wrong about this, and I'm going to examine the board right now, and we're going to try to find this short. But this is our clue. This is consistent with all the feedback that I got on the previous video, and it is consistent with how the device behaves. So how does one find a short on the board, or in the case like this? Well, we're gonna have to inject some voltage. But before I do that, I'm gonna turn it on, and I'm gonna try to locate it first. I'm just gonna cover this chip with a piece of aluminum foil or something, just to cover the heat, so it doesn't distract my camera. And I'm gonna look around. Maybe I'll get lucky. If not, we're gonna have to inject the voltage to this rail. Now we're gonna be injecting maybe, well, up to 1 volt, maybe 1.1, 1.2, but no more than that. On the output on this rail, we should have roughly 2.5 volts, and I'll check that in a minute and confirm that the voltage we have is exactly the voltage we need. Because now, what's going on? If the output of the LDO, it goes through maybe a couple resistors, right? One to the EC, the other one to the other, LDO rail. The voltage will drop, right? As much as the resistor allows it. So abnormal current is going to flow. So the chip is going to start getting warm, but not enough to take away the rest of the current from the EC chip. So EC chip, say it needs 2.5 volts, but it gets 2.1 instead of 2.5. It will still work, and the computer will behave like it's behaving right now. The EC chip will turn on, and it will work perfectly fine. But the voltage is lower because we have abnormal power consumption somewhere on this rail. So I'm pretty sure we're going to find it on the LDO. Now we just need to actually... Okay, let's get to it. Okay, I have no idea. So, no shorts anywhere. The only low resistances that I see is around 20 ohms, 20 ohms on the PCH and 22 ohms on the CPU memory. Now, when I hook up the oscilloscope, I do get a little something on the memory indicating that it is trying to turn on, but not enough even for the oscilloscope to trigger. It's like just burst of tiny energy. No shorted transistor that controls that, and the chip also seems okay to me. It is powered. PCH voltage goes to 0.8 or 0.85, whatever. The same as 5 volts and 3.3, right? But here's the issue. So when I connect the charger, nothing really happens. It's not charging the battery. I thought it was charging the battery because we had 16 volts on the battery. But we have 16 volts on the battery because the battery is producing that voltage. So as soon as I connect the battery is engaged, and a BQ chip opens the transistor to supply the computer from the battery, and it blinks, right? This charging diode over here flashes every few seconds, but only on the battery. When I just connect the power, pretty much nothing happens, but it is fluctuating. So it will go to like maybe 0.1 watt, a few milliamps, and die. Go up and die, up and die. But I don't see any shorts. The LDO is at 3.5 volts. It should be 3.3, but I checked because this is the this is adjustable regulator. I checked the resistances of the resistors, the configuration resistors. There's a voltage divider, and they're exactly as what the schematics say, or the board view. So I don't see any problems there. It feels to me like there is no short, but not a short in the way that we can find it, right? I checked the entire LDO route, every single component, everything. No shorts, not even low resistances, nothing like that. The LDO is constantly 3.5 volts. It works fine. It looks like that regulator is heating up, but it's 35 degrees. That's not overheating. 35 degrees is fine. You can't even when you touch it, you can't even feel it because the body temperature is 36, right? So you can't even feel it getting warm. So definitely there's no problem there. This is not LDO problem. What I do think is going on here, because we did have a port replacement, and some components, it could have been moved, knocked off, or otherwise damaged. So what I think is going on is that the computer is turning on and then immediately turning off because something is not right with the kind of a feedback circuit, right? But this is going to be crazy to find, if that even is a problem, because we don't know. We don't necessarily know the power sequence of this, but that one missing transistor, could this be the problem? But that transistor it just basically shuts off the BQ chip, nothing more, if there is no ground. So if you remove that transistor, it just doesn't shut down the BQ chip. So it should be fine. Yeah, I don't know. I really don't know. See, the problem with devices like this, right? This isn't the board that came to me, the computer was working and it suddenly stopped working and I get the board. There was a lot of prior work on this board. So at this point, we have to consider that something has been, as I said, just, one cap missing or one resistor flew off, right? Tiny, tiny little resistor nobody noticed. And that's what's causing the issue. We have to consider that at least. But I really don't know what to do with this. There's, short I can find, short I can fix. But now I could connect USB-C, see if it's going to charge from USB-C. But if I'm connecting the battery and it flashes on the battery, definitely something wrong. But it's not a short. It looks like it's just consciously turning off. But why does it turn on the PCH 3.3 and 5? Not memory, not CPU memory. I even removed the memory modules just in case, but made no difference. So why does it turn on for a few seconds before it turns off? It's got to be a power sequence issue. I don't see any other explanation. Do you guys have any ideas? Because yeah, the short on LDO, it was an excellent idea and that would definitely explain it, but no, it's not. LDO is fine, 3.3 is fine, 5 is fine, 0.8 for PCH is fine, memory low, but the CPU resistances 3 to 15 ohms, GPU shouldn't really matter. You know what I'm gonna do? I think let's just quickly check, but no, that would definitely be visible here. But let's just check again the VRMs on CPU and GPU. It's good. But if the VRM was shorted, then no, that would behave differently. What I'm gonna do is I'm gonna run this board through the ultrasonic cleaner a few times, right? Get it nice and clean, because right now that section that this was replaced, right? You can see the solder blobs and all that. But we have so much mess over here, right? There was some liquid metal, so this could be also, there might be a little bit of liquid metal somewhere, right? There might be a solder blob, and I even see something over here. What is that? Is that a solder blob? Oh, that's liquid metal. And that's solder blob. Yeah, this is liquid metal over here. Is it? I'm not sure. Yeah, it looks like liquid metal. So there might be liquid metal somewhere making a short, and that's causing the issue. Or liquid metal mixed with flux, and that's causing the issue. In either case, this needs to be cleaned. And I guess we'll see after cleaning, but that's not gonna happen today. Now, yeah, consider, look at the size of this resistor, right? If there was another resistor here, or here, or here, right, or here, we're not gonna know that. I mean, we can compare it with the board view, but some components are just naturally not unpopulated on certain models or certain versions of certain boards or of the boards. So this could be normal. These are all unoccupied. It could be fine, or we're missing something somewhere, and that's what's causing the issue. So this is going to be very tricky to figure out. But correct me if I'm wrong in the comments, that this is definitely not a short. The thermal camera shows nothing. I checked every single coil, I checked every single transistor, like completely blindly, going through the board. Because if I can't find anything, then I just, resort to blindly checking everything, right? Maybe I'll get lucky, right? I did not get lucky. But no, I conclude that this is definitely not a short, even though it behaves like it's a short. It feels like once it goes into charging, it just self-terminates. And not even into charging, because as soon as I connect the battery, it flashes. So it's trying to turn on, and it can't, for some reason. Well, if you guys have any ideas, I would definitely appreciate some input here, because I'm kind of, well, maybe not necessarily lost, because I do have a way forward, and I want to just go through every component along the charging route, every component, and I'm going to go through the board view and just every component, because this is a pretty good board view which shows you the values of the names and values of the components. So I will just check one by one every resistor, every capacitor, every diode, everything, and we'll see. Maybe that will produce some results. But if you guys have any ideas, definitely let me know, and I'll check that as soon as I can. Until then, thank you guys very much for watching. I do appreciate you, and I shall see you in the next one.